We have our goal right there. It says, by the end of this class, I'll be able to solve systems of linear equations by graphing. But before even going over that goal or talking about what a system actually is, this first part of our handout, the top left-hand side, is a class opener. So let's just walk through this right here. Number 1A, what is the solution to an equation? So how about this? Let's put an equation right here. X plus 2 equals 5. What's the answer there? 3. The answer is 3, right? Okay, so the answer is x equals 3. That's the answer. Now the question is, why is that the answer? Why? Because 3 plus 2 equals 5. Because if you take the answer 3 and you plug it in, it works. So what is the solution to an equation? It's a value that makes the equation a true statement. Okay? It's the number that'll make the equation a true statement. So you guys could write that down. So there it is. The value or values that make the equation a true statement. So once again, if you plug in 3 right there, 3 plus 2 is 5. That's a true statement. If I plugged in a 4 right here, 4 plus 2 is not 5. That would not be a solution. It's not an answer because it's not a true statement. Moving on to the second part. It says, name 3 solutions that work for this equation, x plus y equals 3. So go ahead and tell me. Give me 3 answers. 0 plus 3. Okay, so what you're saying is x could be 0, y could be 3. But instead of wasting time and writing it like that, we know that ordered pairs have an x value first and a y value second. So you could write it as an ordered pair, 0, 3. That is one answer to the equation x plus y equals 3. Give me another answer. 1 and 2. Okay, so let's write it as a ordered pair, 1, 2, because 1 plus 2 is 3. What else? Negative 1 plus 4. Okay, that'll work also. How many answers are there? There's only 3 answers that work? No. There's an infinite amount of answers, right? So right here I'm just saying name 3 of them. We named 3 of them. 0, 3, 1, 2, negative 1, 4. I could have done 8 and negative 5. I could have plugged in 100 and negative 97. So you could just keep going, right? There's an infinite amount of answers. And that's one of the reasons why we graph equations, which kind of leads into the second question here. When you graph an equation, what does that line really represent? When you graph a line, it does have a slope, rise over run. But what does that line actually represent? The what? How about this? In order to answer number 2, let's jump to, or 2A, let's jump to 2B. Let's actually graph x plus y equals 3. Last semester, we learned how to graph. We learned different ways on how to graph. You could use an XY table, or you could put it in slope-intercept form and then graph it. So what do you guys prefer to do right here on 2B? Subtracting x would start, you'd be able to write it in slope-intercept form. So let's do that. Let's subtract x, and of course, x take away x is 0, so it's gone. So let me rewrite my equation now. I'm going to have a y equals negative x plus 3. All I did was rewrite what I had left. Y equals the negative x and the positive 3. There it is. Y equals negative x plus 3. And now we recognize that it's in the form of slope-intercept form. We rewrote it in slope-intercept form. So this is rewritten in slope-intercept form, which is y equals mx plus b. And what does that mean? That means we could look at the equation that we now have in red up here, and we could identify the m. What's the m? What's the slope? Negative 1 over 1, right? Negative 1 over 1 is the slope. And what's the b value? The b value is this guy right here, 3. So once you know the b, which is the y-intercept, and you know your m, which is rise over run, which is down 1 over 1, you could graph your line. So if I go to the y-intercept of 3, put a dot right there, and then from this dot, I actually go down 1 over 1. Remember, the negative means that you're going to go down instead of up, right? If that would have been a positive, you'd go up. But because it's negative, you're going to go down. And the run, you always look at it from left to right, so you always run to the right. So you're going to go down 1 over 1. If this would have been a negative 2 over 3, you would have gone down 2 over 3. If it would have been up or positive 3 over 4, then you'd go up 3 over 4. So I hope you guys remember that from last semester. The slope just tells you rise over run. So in this case, the rise is negative 1, which means I go down 1, and I run 1, so I put a dot right here. So let me do that. Put a dot right there. And I could continue with the same pattern of going down 1 over 1, going down 1 over 1, down 1 over 1, and I could continue putting dots right there and right there. And you could draw your line. You only need 2 dots to draw your line. We put arrows on it because it continues forever. So we just graphed this from remembering slope-intercept form from last semester. But the question is, why did we graph this? What does this blue line represent? Why does it have arrows on it? Mark, help me out. Why does it have arrows on it, first of all? To show that, okay, that it continues forever. Vanessa? Okay, so yeah, the arrows means that it continues forever. If we take a look at the same equation up here, you guys came up with 3 answers. X plus y equals 3, same equation, x plus y equals 3. We graphed that equation. Here's the blue line. If I look at the answers that you guys gave me, 0, 3, 0 on the x, 3 on the y, there it is. 1, 2, 1 on the x, 2 on the y, there it is. Negative 1, 4. Negative 1 on the x, 4 on the y, there it is. So this blue line, it actually represents what? It represents every single answer that exists to the equation x plus y equals 3. How about this? Let's get a little crazy. Let's think about certain 2 numbers that would add together to give me 3. But let's talk decimals. Give me two numbers that are decimals that add together to give me 3. Anybody? Think about money. Give me some change. Help me out here. $1.50, 1.5, and 1.5, right? $1.50 plus $1.50 is $3. So in this case, 1.5 plus 1.5, it also equals 3. So if you go to the graph that we just did, that 1.5 and that 1.5 is going to be right there. Check it out. Here's the origin. 1 and then 0.5 is halfway. And then up 1 and then halfway is right there. So even decimals are right there, right? 1.5 and 1.5. So what I'm trying to get at here, and we've already explained this in semester 1, that when we graph a line, it represents every single solution that exists to the equation, right? I mean, we already know that an answer could be 100 and negative 97. That'll also give me the answer 3. So if I did go from the origin to 100 way out here and then negative 97 way down here, it will land perfectly on that line. So this line represents every single answer that exists to an equation. That's why we graph. Okay, so why do we graph a line? What does that line represent? Every single answer to the equation, all right? How many answers are there to an equation x plus y equals 3? How many answers are there?
2.
Infinite. It goes on forever and ever and ever, right?
When you first asked that, I said it.
So let's go back to number 2a, and it says when you graph an equation, what does that line really represent? It represents the infinite amount of answers that exist to that equation. Let's move on to the notes, the actual notes for today. And you guys aren't copying them down, you're just reading along right there on your handout. We're talking, guys. Okay, so vocab term number 1, a system of linear equations. When you guys think of the word system, what do you think of? Give me anything that comes to your mind when you hear the word system.
No, I don't know.
You don't know?
A work in progress.
A work in progress. Anybody else? System. Austin, system. What comes to your mind? Doesn't have to be even related to math, whatever. Just what comes to your mind when you hear the word system?
Think of like the system. Police.
The police. Okay. Well, the police, it is consistent. It does have an order to it and many parts to it, right?
The second thing that comes to my mind is like PS4.
PS4, right? That is a game console. It has a system, PlayStation system, right? So the system has many parts to it. It has the console itself, has the controllers, has the games, has many parts to it. So a system, system. So a system just has many parts. I mean, think about a radio system, right? A sound system. It's not just about having the radio. You have to have the right speakers, the whatever other parts it has to it. So a system of equations is really just two or more equations together, working together. Now, a solution to a system, so let me give you an example of a system of linear equations. Maybe you have the x plus y equals 3, that same equation we've been working with. And maybe we have a different one that says 2x, let's go, minus y equals 9. Okay, that is a system right there. There's two equations. It could be more than two, but this is a system of equations. There's two equations. And I'm going to ask you to find the solution to this system. Okay? So how many answers are there for this top equation? You guys just told me there was an infinite amount of answers. How many answers are there for the bottom one? There's also an infinite amount of answers. However, we want to find that one common answer that works for both. Okay? So when you're trying to find the solution to a system, you want that one answer that works for both. So off the top of your head, give me one answer to x plus y equals 3. What do we say? X plus y equals 3. What's an answer? Any answer. 1 plus 2. Okay. So if we say 1 and 2, maybe we're guessing that the answer is going to be 1 comma 2, that x is 1, y is 2. However, when you plug in 1 for x right here and 2 for y right here, 2 times 1 is 2, minus 2, that would be 0, not 9. Does that make sense?
Yes.
So this answer, 1, 2, it does not work. Why not? Because it didn't work into the second equation. It worked into the first, but not the second. So there's about 36 of us here. Could anybody guess the right pair of numbers that work for both? Come on, guys. I want to pause it so we don't take more time on the video here, but so if we were to try 0 for x and 3 for y, would that work? If you plug in 0 plus 3, it is 3. That works for the top one. But does it work for the bottom one? 2 times 0 is 0. 0 minus 3 is not 9. So it does not work for the bottom one. So, I mean, we've been here for a while. There's so many of us. Do we have an answer? What is it?
4 and negative 1.
4 and negative 1 is the correct answer. Excellent. All right. Now, that did take a while, right? 4 and negative 1. That is the answer for this particular system. Why is that? Because it works for both. Check it out. 4 plus negative 1, that is 3. 2 times 4 is 8. Minus a negative 1, that's really plus 1. It's going to give you 9. So 4 and negative 1, it really does work for the top equation and the bottom equation on that system. Okay. Now, believe it or not, the pair of numbers 4 and negative 1 are the only pair of numbers that work. So 4 and negative 1 is the only pair of numbers that actually works for this system. Okay, now let's actually talk about other vocab words with regards to systems. We have consistent and we have inconsistent. Okay, and I guess the best way to understand the difference between consistent and inconsistent, and also consistent independent and consistent dependent, is when we look at the word wall that we have over here on the side wall. I actually took a picture of it, have it right here. So what is a consistent system? It means that it has an answer or maybe an infinite amount of answers, but there are some answers, right? It either has one answer or an infinite amount of answer. Check it out. This system, if I graphed the blue line, graph the yellow line, it has one answer only, right? Now, if I graph the blue line over here on the side, and I graph the yellow line, it's the same line, so technically it has an infinite amount of answers that are in common. But the bottom line is a consistent system has one answer or maybe an infinite amount of answers. Now, if it just has one answer, then that's what we call a consistent independent system, okay? Andrea, if I asked you, are you financially independent of your parents? What does that mean? Anybody? Being financially independent of your parents, what does that mean?
That we rely on them.
You don't rely on them financially. You don't ask them for money. You pay your own rent. You pay your own cell phone. You pay your electricity, gas. You pay your own car payment, all, whatever, right? So independent means that you're on your own, right? One person, you're independent. You don't depend on anybody. So when you're talking about a consistent, independent system, you're talking about one answer only. Now remember what we said earlier. When you graph a line like this blue line, you have an infinite amount of answers. When you graph another line, you have an infinite amount of answers. And if you're looking for that one answer that works for both, I mean, yeah, you could guess and check the way we did earlier, but that takes a long time. If you were to graph them each and you find the point of intersection, that'll be the point that's in common that works for both. Does that make sense?
Yes.
Okay? And the word for that is independent. Why independent? Because there's one answer only. Okay? Now, a consistent dependent system is when you have two equations, you graph both of them and you realize that it's the same exact line. So if you have the same exact line, how many points are in common right there? There's an infinite amount of points in common. And so notice that the blue line lands perfectly on top of the yellow line. Now, when you're on top, like if you're giving somebody a piggyback ride, they're depending on you, right? So a consistent dependent system is when one line lands perfectly right on top of the other line. And that's on the word wall. It's going to stay right there. Now, when we look at an inconsistent system, that means that they have no answers in common. Again, remember, a line represents the infinite amount of answers of an equation. The other line represents the other infinite amount of answers to the other equation. And if you're looking for the answer to the system, you're looking for that point that they share. The point that they share, which means the point of intersection, right? So if they don't cross, and I tell you to find the answer to the system, what do you say? You say that there is no solution. There is no point of intersection. There is no point that they share. So I hope we cleared that up. This is on the wall. Once again, final time I say it, consistent means that there's answers. Now there's two types of consistent systems. There's a consistent independent, which means it only has one answer, and there's a consistent dependent, which means an infinite amount of answers. These are consistent systems. Two types, independent, dependent. These are inconsistent, which means they have no answers. Again, remember, no points in common means that they don't share any answers, so it would be a no solution system if I asked you to graph one of those or solve one of those. Anyways, let's jump up here. The goal today is to be able to take a system of equations, kind of like, where's the system I made up? This system right here, x plus y equals 3 and 2x minus y equals 9. You could technically rewrite this in slope-intercept form, y equals mx plus b, and graph it. You could write this one in slope-intercept form, y equals mx plus b, and graph that line. And if you graph both of them correctly, both lines are going to cross where? We said that the answer was 4, negative 1. That would be the exact location of the intersection of these two lines. Okay? So instead of guessing the way we did right here to get the actual correct answer, we're going to actually graph them, find the point of intersection, and that will be our answer to the system. So let's go over here to number 1. So on number 1, we have a system. Simply means two or more equations working together. Now, I bet it would be very difficult to start guessing, oh, x is 3 and y is 4 and see if it works, right? And it has to work for both x and y up here and x and y down there. So the best way to do it is to graph it. Now, the top equation is already in slope-intercept form, so the top equation is really easy to graph. Let's graph that top equation. Where does it cross the y-axis? What's the b value? It's negative 2. So it crosses right here at negative 2. Now from that point, how much do I rise and how much do I run? And remember, we're looking at this top equation first. So how much do I rise and how much do I run? In other words, what's my fraction in front of the x value? Negative 3 over 1, right? That's the slope. The slope in front of the x is negative 3 over 1. That's my m value. We said that this one over here was our b value. But anyway, from that point, I'm going to go down 3 over 1. So I'm going to go down 1, 2, 3 over 1. I'm going to put a dot right there. And not only that, I'm going to go backwards. Instead of down 3 over 1, I'm going to go over 1, up 3, over 1, up 1, 2, 3, and I'm going to put a dot right there. And also over 1, up 1, 2, 3, put a dot right there to extend it as far as I need to. And then, of course, draw my line right through it with arrows. So this blue line truly, actually, let's make it a red line. This red line truly does represent every single answer that exists to this circled equation that's in red. Okay? Now the other one, I still need to graph it, and the other one's in standard form, not slope-intercept form. So let's get in slope-intercept form. Let's get y by itself. So I'm going to subtract 2x, and I'm going to rewrite it. It's going to be 3y. By the way, you guys should be following along on your notes right here. 3y equals negative 2x minus 6. And then I'm going to divide by 3 to get the y by itself. So my final slope-intercept form equation for the bottom equation is y equals negative 2/3 x minus 2. So this is my bottom equation. I just rewrote it. From standard form, I changed it to slope-intercept form. So where's this one going to cross the y-axis at? This blue equation, where does it cross the y-axis? Negative 2. Let's put a dot right there at negative 2. Wait a minute, it's the same exact b value. That's great. Now, what's the slope from negative 2? What's the slope? Negative 2 over 3. So I'm going to go down 2 over 1, 2, 3, and put a dot right there. Once again, we went down 2 over 3, put a dot right there. And you could go backwards, over 3 up 2, over 3 up 2, and get the dot right there. And you could extend your line as far as you need to. Where's my point of intersection? Austin, what's my point of intersection?
Is it
It's right here. And that coordinate is the coordinate 0, negative 2. Okay, what does that mean? X is equal to 0, y is equal to negative 2. So once again, what we did here was we graphed the blue line, which was the bottom one. That represents every single answer that exists to the blue one. We graphed the red line. It represents every single answer that exists to the top one, the red one. And you want to find that single point in common. That would be the point that overlaps. That would be the location 0, negative 2, which gives you the answer 0, negative 2, 0 for x, y being negative 2. And that is your answer to that system. The only other thing you could do is to plug it in and double check and make sure that it actually works. So on the top equation, which says y equals negative 3x minus 2, if I were to plug in a 0 for x and a negative 2 for y, you'll verify that it does work. So instead of y, I'm going to put negative 2 equals, and then I have the negative 3 times x, but x is 0 in this case, and then minus 2. You'll see that it really does work out, because negative 3 times 0, that's just 0, and negative 2 really does equal negative 2. So you have verified that it works for the top one. That's why I put a little check mark right by it. You could also verify that it works for the bottom one. You could take the 0 for x, put it right there. You could take the negative 2 for y and put it right there. So a 0 right here would just make it disappear. So you'd really have 3 times negative 2. That really is negative 6. So as you can see, it does work for the bottom one also. So the coordinate 0, negative 2, that is the solution to the system, and we did not guess at all. We graphed the top equation, graphed the bottom equation, and the point in common is the answer that works for both. Are you always going to have one answer that works for both? No. Sometimes if you graph the lines and they're parallel, that means they never cross. That means it's inconsistent. That would mean that you have no solution, no answer in common. Or sometimes you graph one equation, graph the other equation, and it ends up being the same exact line, that means that it's a consistent dependent system, which means that it has an infinite amount of answers. Let's check out number 2 down here. So the top equation is not ready to graph. So what I want to do is I want to change it up. In red, I'm going to modify it. What would I do to get it ready to graph? What do I do to get ready to graph? I need y equals mx plus b. Daniela, help me out. What do I do? How do I do that? Add 2x. So if you go plus 2x here, plus 2x over here, I could rewrite it. Let me write it in red. Y equals 2x minus 3. Now, the bottom equation is already ready to graph. Y equals negative 3x plus 2. Okay? So the top equation in red, where does it cross the y-axis? What's the y-intercept value? Negative 3. And the bottom, and the top red equation, what do I do from that point? What's my slope? What do I do from here? Up 2 over 1, put a dot right there. And of course, you could continue up 2 over 1, up 2 over 1, up 2 over 1 to make the line as long as you want. You could even go backwards, down 2 over 1 the opposite way. Let's draw our line right through those dots. Put arrows because it's infinite, it continues forever. And now let's do the same for the bottom one. Where does the bottom one cross at? Crosses at 2, right here. Now what do I do from there? Do I rise or do I drop? What do I do? Drop 3 over what? Over 1. So if you drop 3, 1, 2, 3 over 1, you're going to end up at that same point. So you could continue to drop 3 over 1, and you could even go backwards, up 3 over 1 the opposite way. But the bottom line is, we're looking for the point that's in common. What's the point in common, guys? It is the coordinate positive 1, negative 1. Positive 1, negative 1. Again, from the origin, on the x, you go positive 1, and then you go down 1. So it's positive 1, negative 1. That's the answer. Now, what does that mean? That means that x equals positive 1 and that y equals negative 1. And if you do plug it in to verify, you'll see that it really does work for both equations. Okay? Moving on. Number 3. Is the top one ready to graph? Yes, it is. It doesn't have a slope. There is no mx, right? So you could write it if you wanted to, y equals 0x minus 1, just to show that there is no slope. And if there is no slope, you know that it's totally flat. It's not steep. So it does cross at negative 1. It does not have a slope, so it's a totally flat line. Put some arrows on it. Now the other one's not ready to graph. I'm going to use a different color for the other one. I want to subtract 3x, subtract 3x. Now it is going to be ready to graph. Y equals negative 3x plus 5. Where does it cross the y-axis? 5. Way over here on the edge. What do I do from that point? What's my slope? Down 3 over 1. Down 3, right 1. So if you go down 1, 2, 3, right 1, there it is. Down 1, 2, 3, right 1, there it is. Down 1, 2, 3, right 1, there it is. And of course, we have our line going through all those points. So the blue line, the blue equation, has an infinite amount of answers. The red equation has an infinite amount of answers. I'm looking for that one answer that works for both. What is the answer to that system? 2, negative 1. Perfect. Right here. The point of intersection. The x and y values that's being shared by both lines. So 2, negative 1, that's your solution. X equals 2, y equals negative 1. That's your answer. So if you go back to the original system and you plug in a 2 for x, see there is no x, but a plug in a negative 1 for y, it works. Negative 1 equals negative 1. So it works on the top equation, check. And if you try on the bottom, x equals 2, 3 times 2 is 6, y equals negative 1, 6 plus negative 1, it really does equal 5. So right there you checked, you double checked. So there is no excuse for you to miss any questions. You could always take your answers that you got, plug them in, and if it works for both, you've double checked it, you're absolutely positive that you found the answer to that system, the correct answer to that system. Quick style. Number 4, the top equation. Let's go in red. Where does it cross the y-axis? 3. Thank you for answering. What do I do from that point? Up to the right 1. Always to the right. And then let's use this same pattern but backwards. I mean, 1 this way, down 2. 1 this way, down 2. And so on and so on. So you can make the line as long as you want. And then you draw your line. Whoops, kind of crooked, sorry. Let's go for the other one in blue. Crosses at -5. Right here on the edge. What do I do from that point? Up to the right 1. 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 Draw your line. Ladies and gentlemen, if I'm looking for the answer that works for both, what does this graph tell us?
It's inconsistent.
That it's inconsistent. Now, what does that mean in terms of answers?
There's none.
There is no answer. So you would say no solution. No solution. Now, if they told you classify this system, if they tell you classify, I mean, the answer is no solution. But if they told you classify, this is what we call an inconsistent system. They don't cross. There is no answer. Okay? Let's go back to one that we already did. Up here, if I told you to classify it, you would say it's a consistent independent because there's only one answer. Same thing over here. It's a consistent independent because there's only one answer. Okay? But down here, the answer is that there is no answer, no solution. But if they asked us to classify it, that's where you would say inconsistent. Let's look at the last one on this worksheet here. So the top one's not ready to graph. Let me do it in red. I'm going to have to divide everything by 2 to get it in y equals mx plus b. I will have y equals 4x plus 6. And there's my red equation. On the bottom one, let's do it in blue. Let's get the y by itself. I'm going to go plus 4x plus 4x. You're going to have y equals 4x plus 6. Ladies and gentlemen, do I even need to graph this? Why not? They're both the same exact line, ladies and gentlemen, right? Y equals 4x plus 6 and y equals 4x plus 6. If I were to graph it, okay, well 6 is off the graph. And then if I go up 4 over 1, or the opposite way, down 1, 2, 3, 4 over 1, then down 1, 2, 3, 4 over 1, down 1, 2, 3, 4 over 1. So here's my red line. And then if I were to graph the blue line, it's going to be the same exact line. So if I'm looking for the point that is in common, the point that is shared by both, is there one point that's shared by both? Or is there an infinite amount of points that's shared by both? Infinite. So you have all these points. Every single point on there is shared. So when I say what's the answer, you say infinitely many solutions. That is the answer, that there's infinitely many solutions. Now, it's a completely different story if I ask you to classify it. Let's do that. Classify. What does that mean? Give it a name. So we already know that there is an infinite amount of answers. But if they want us to classify, to give this system a name, that's where we say consistent, dependent. Because the lines land on top of each other. They're dependent. There's an infinite amount of answers. Okay, so the classification is consistent, dependent, but the actual answer to this thing, when I'm asking what is the two numbers that work, well, there's an infinite amount of numbers that work. So that's all you need to know. 34-minute video, dang. Sorry, it's a long video. That's all you need to know about systems and solving them by graphing. There is no guesswork. You just graph them and find the point of intersection.